Hello, classmates. Today we continue to study on the topic of sinusoidal alternating current. When calculating power in direct current, we know that power equals to the product of the voltage magnitude at both ends of the element and the current magnitude. However, in an AC circuit, the load may not be purely resistive. So, how do we calculate power in such cases? With these questions in mind, let us delve into today's study. First of all, let's study the instantaneous power of sinusoidal AC circuit. We have a passive two-terminal network. As shown in the following figure, the port voltage and current are given by U equals UM sine omega t plus phi, and I equals IM sine omega t. Here, phi represents the phase difference between the port voltage U and the current I. The expression for the instantaneous power on the load should be equal to the product of the instantaneous voltage and the instantaneous current, namely P equals UI equals root 2 times U sine of omega t plus phi times root 2 times I sine omega t equals UI cos phi minus UI cosine of 2 omega t plus phi. The expression of instantaneous power is obtained from calculation. It can be seen that instantaneous power is sometimes positive and sometimes negative. When it is a positive value, it indicates that the load absorbs power from the power supply. When it is negative power, it represents the release of energy from the energy storage element in a slave load and sending it back to the power supply. Next, we will learn about active power, or the calculation of average power. The average value of the instantaneous power, known as average power, or active power. It calculated as follows. By multiplying the effective voltage and current values, and then multiplying this by the cosine of the phase difference between the voltage and current. As can be seen from the above formula, the active power of a sinusoidal circuit has an additional multiplier cos phi compared to the power of a DC circuit. Here, phi represents the active power of a sine circuit, which is not only related to the effective values of voltage and current, but also to their phase difference phi. The term cos phi is also known as the power effect. The unit of active power is watts, abbreviated as W, and represented by the letter W. Next, let's learn about reactive power. Due to the presence of energy storage elements in the circuit, such as inductors or capacitors, although they do not consume power, they exchange energy with the power supply. Reactive power is used to represent the magnitude of this energy exchange. It is denoted by the uppercase letter Q. For the passive network shown in the above figure, its reactive power Q is given by Q equals Ui sine phi, where angle phi is the phase difference of voltage and current. For inductive circuits, when phi greater than 0, sine phi greater than 0, and the reactive power is positive. In this case, the circuit absorbs power. For capacitive circuits, when phi less than 0, sine phi is less than 0, and the reactive power is negative. In this case, the circuit emits power. The unit of reactive power is var. Reactive power is generated by the exchange of energy with the power supplied through energy storage elements. It can be expressed by the following formula: Q equals QL minus QC. Although reactive power does not consume energy, it cannot be considered useless. Reactive power is as important as active power. For example, the electrical equipment of enterprises mostly operate based on the principle of electromagnetic induction. For example, transformers, welding machines, and electromagnetic induction motors. They all rely on the conversion of electrical energy into electromagnetic energy, which is then further transformed into electrical or mechanical energy. For energy conversion, in this way, consumer electrical equipment must absorb two kinds of energy from the power grid. Part of the energy is used for doing work, such as mechanical or thermal energy mentioned earlier. This part of the energy is mainly to meet the needs of production and life, which is active power. Another part of the energy is used to generate an alternating magnetic field. It is essential for devices like transformers, welding machines, or inductive coils, which are involved in energy conversion and transmission. Without the magnetic field, there is no media for transmitting energy, and the energy can only be consumed within the power supply or the electrical equipment itself. It cannot be transmitted externally or perform external work. This part of power is reactive power. Now let's learn about calculation of apparent power in sinusoidal circuit. Product of effective value of voltage and current is called apparent power, represented by S, and is measured in volt amperes or kilovolt amperes. Its expression is S equals Ui. Apparent power usually represents the capacity of electrical equipment, indicating the maximum power that the electrical equipment can possibly convert. Common electrical equipment includes transformers and generators, etc. The active power they emit is related to the power factor of the load, rather than being a constant. In conclusion, active power, P reactive power, Q apparent power, S, there are the following relationships among them. P equals Ui cosine phi equals S cosine phi. Q equals Ui sine phi equals S sine phi. S equals the square of active power and the square of reactive power, and it is also equal to the square root of the sum of their squares. Additionally, S equals UI. Phi is equal to the ratio of reactive power, working power, and is determined by the arctangent function value. It is an included angle used to form a power triangle, with S as the hypotenuse and P as the adjacent side, emitting the voltage triangle. As shown in the figure above, then the other right angle edge is reactive power Q. In this lesson, we covered the calculation of AC electrical power, with a particular focus on gaining a deep understanding of reactive power. In real life, there are many cases of reactive power. I hope that all students can become adept at recognizing and exploring these instances. Classmates, see you next class.